So. Good morning, ladies and gentlemen, esteemed partners and experts and startup enthusiasts, and welcome to our inaugural edition of H2UB Insights. I'm Robin from H2UB, and I'm thrilled to be your moderator today for this exciting live session, where we will embark on a journey into the future of the hydrogen startup economy. Throughout this series of short and crisp live sessions, we will explore the newest developments and innovations in the hydrogen startup ecosystem. Today, we are here to shed a brilliant light on the profound transformations taking place in the energy landscape. And as we move towards a sustainable future, it's undeniable that green hydrogen will play a pivotal role in the global energy transition. But the question is, how do we ensure that we have the necessary infrastructure to produce green hydrogen efficiently and even at a large scale? To answer this crucial question, we have gathered an extraordinary lineup of visionaries, partners, and experts from BROCKHAUS Group, the Department for Production Systems from the Ruhr-Universität of Bochum, and the WEW GmbH in Dortmund. And together today, we will delve into the realm of automation in stack production and its potential to revolutionize the electrolyzer economy. By harnessing the power of automation, we aim to unlock a new era of increased efficiency, cost reduction, and higher production capacity for electrolyzers. Our esteemed panelists today are Dr. Harald Bock from BROCKHAUS Group, Robert Egel from the Department of Automation from the Ruhr-Universität at Bochum, Dr. Gregor Polcyn from the WEW GmbH, and Idris Yorgun from the RIF project. And together we will bring wealth of insights and experience to the table. Their collective expertise will undoubtedly provide us with invaluable knowledge. And let's see how this works out. And so further ado, let's begin with our groundbreaking session as we uncover the potential of automation in stack production and its profound impact on the green hydrogen landscape. So I'd like to welcome our distinguished guests and panelists. Good morning, guys. How are you doing? Thank you for being around for today.
Morning. Thank
Hi.
you.
I think at first our four guests will introduce themselves and show you why they are qualified for our session today. And then we will go on with our context. So from the Hub network, I'd like you, Robert, to start off to introduce. Good to have you here.
Yeah, thank you very much. Thank you for having me here. It's a great pleasure, not pressure, pleasure. My name is Robert Egel. I'm currently working at the Chair for Production Systems at the Ruhr-Universität Bochum. And currently I'm the project leader for the H2Giga Fertirob project. This is a project which is included into the overall H2Giga environment. And this environment has the goal to increase the hydrogen production capacity in the next few years with the help of various research projects, practical projects, also with big partners, with smaller partners, etc. And we, from the Fertirob project, our goal is to increase the output, the production output of the machines which are producing the hydrogen. In this case, the electrolyzer stacks and the electrolyzers themselves. Exactly. And I would like, first of all, to have a cool discussion with all of you guys. And the second point is what I want to mention here is that maybe we can enlighten a sparkle for some people who think that, yes, automation of our product, especially in the hydrogen context, is important, but not for now. And maybe we can share our vision and say, yes, maybe right now is a good time to think about or start to think about automation. So we can gain our technical leadership as soon as possible or as early as possible. Thank you.
Thank you, Robert. Idris, could you go on?
Yeah, of course. Hello, this is Idris Yorgun. I'm a mechanical engineer and working as a research assistant at the RIF Institute for Research and Transfer. I'm also part of the H2Giga project like Robert, where I am mainly working on production and automated technologies on the automated manufacturing, for electrolyzer and stack manufacturing. Also for me, it's a pleasure for me to be here today and have the chance to share my point of view in terms of this innovative and interesting topic. Thank you.
Thank you. Next up, I'd like you, Gregor, to introduce.
Thank you, Robin, for the invitation here to this call. My name is Gregor Polcyn. I'm of the three founders and managing directors of WEW. So inside of our company, I'm responsible for the production technology of our stacks. And from background, I have more than 15 years of hydrogen experience in my back. So our company is a startup in the field of stack manufacturing, development, and production of water electrolysis stacks. So we are founded roughly 2.5 years ago, and now in a phase where we start with say first manufacturing steps, and later on with the automated manufacturing, where we're already planning the full integrated and automated manufacturing of electrolyzer stacks.
Great, thanks you. Good to have you around today. And last but not least, Harald, please give us the
thanks, Robin, for inviting me to represent BROCKHAUS Hydrogen. I do lead our new business unit, BROCKHAUS Hydrogen, with the target to accelerate green hydrogen as safe, reliable, sustainable, and affordable as possible. For that reason, our team at BROCKHAUS developed a new electrolyzer called BlueTube together with our strategic partner WEW. Today, I'd like to share some thoughts on our view on our technology selection, where automatization was a key role.
Okay, great. So to introduce the session and our audience to the topic which we want to talk about today, I would ask you, Robert, please, to give us a glimpse on what you're doing in detail at your daily job. And you brought a little presentation for us today. And I would hand over to you to get some insights of what you are doing.
Yeah, thank you very much. Yeah, as mentioned, I'm project leader for the H2UB project, and here for the beginning of the discussion, we decided to present some topics, some tasks on which we're working on, and to share some insights and to share some visions which we have within our project here at this discussion. So, as mentioned, I'm working for the chair of production or for production systems, and we are basically a chair who are working on all kinds of tasks and research which are connected to production. Of course, on the one side, we have the classical production engineering topics with a strong focus on robotics and production technologies. Also, we have some or a lot of competencies regarding assembly technologies, which are especially important when it comes to stack production or electrolyzer production. But on the other side, we are also dealing with topics which are connected to production management. For example, how does or how should a manufacturing organization should look like? We do some qualification or certification for external partners. And we are also thinking about how new trends, for example, virtual reality, augmented reality, can influence production and can help companies in order to increase their output afterwards. Yeah, and this we are not doing in our small hole, but we have two big buildings where we can implement our ideas in the practical term. The first one is the Learning and Research Factory here in Bochum. And here it is basically a big hall with a lot of robots, a lot of machines, where we can program a lot, where we can test a lot, and also where a lot of companies are coming and want to see some new trends which are evolving right now. On the other side, we have a new building. It's called CES, which is also here in Bochum. And here we are not alone in this building, but there are some other institutes from the Ruhr-Universität Bochum. And there we are working together with them on topics where the solution cannot be found only with the help of mechanical engineering, but with the help of other institutes or other topics. For example, psychology or informatics or human resource or similar. Last but not least, we are connected into a strong competence center, which is called Mittelstand 4.0, where we have strong connections to especially small and medium-sized enterprises. And there we qualify them, we demonstrate them, we inform them, and work with them together in various research projects, in order to help and to gain also information for us. The Fertirob project, we have basically two goals within our project. The first one is to find solutions for the automated assembly of stacks and electrolyzers. That means we don't deal only with the stacks, but also have a focus on the overall electrolyzer. And the second goal, which we have, is the reduction of manual planning efforts. As you can imagine, if you plan a big plant, especially for electrolyzers, there are a lot of tasks which have to be handled within this process. And some of these tasks normally take a lot of time. For example, PLC programming, robot programming, finding solutions for small specific cases or tasks. And here we want to find solutions how we can reduce exactly this manual planning effort and to optimize a little bit more in order to faster finish our plant and to faster produce more stacks and electrolyzers afterwards. And this we are, of course, not doing alone, but we have strong partners within our Fertirob project. Overall, we are a very big project. We have 16 partners, 13 from the industry and 3 from the academia view. And mostly our competencies within our project lays in the mechanical engineering, robotics, and automation technology field. On the other side, of course, we have a lot of competencies in the digitalization and in the optical inspection and quality assurance issue. Why? Because we don't only want to produce as fast as possible also, but we also want to do it in a good quality. And therefore we need experts who are saying, hey, this has to be included, these kind of tasks have to be mentioned in order to get the quality which we want after all. Yeah, some exemplary project topics on which we are working each and every day. Of course, one important topic is the automated stack assembly, where we created one demonstrator for us in order to test some various points. First of all, we want to conduct various mechanical tests, especially the stacking and the material delivery, but also we want to integrate quality inspection topics into this demonstrator. And afterwards, we want to design an optimal gripping concept, which can include not only one gripper, but more gripper, because we have various different parts included into one stack, but I think we will discuss it later. The second point, which has a high priority for us, is the handling of stack components. Some of these tasks are also included into the first point, but we see the handling of stack components in the overall process. That means from the moment the parts are coming into our factory until the moment when the stack or the electrolyzer is leaving, we have a view on the overall process. That means, for example, incoming inspection, quality inspection from the beginning is a topic for us, and various other tasks as well. And here we have some challenges, that we have a lot of variation of components and different handling conditions due to individual material properties. Some of them are flexible, some of them are hard, some of them are porous, etc. So they have different conditions, and therefore it is, of course, quite a challenge to automate it. A third point is, as I mentioned it some slides ago, that we focus on the assembly of the overall electrolyzer. But we did analysis at the beginning, and we saw that it is really hard to completely automate the overall electrolyzer, and therefore we decided we want to do a human-robot collaborative assistance with it. So therefore we want to integrate various essential parts, mainly the stack and the control cabinet, but also some other parts, and to see and to have a look how the best way might be in order to optimize the overall process. Another point where we see a lot of potential is the automatic wiring, not only in the control cabinet, but also within the electrolyzer as well, because we have there a lot of wires. The wires are, of course, flexible, they bend in a very different way, and therefore also to have a look, hey, how can we automate the whole wiring process and decrease the time when the electrolyzer is finished. Last but not least, I mentioned one slide ago the fact of quality. And for us, the digital twin for electrolyzers is a very important topic when we want to reach the quality levels which we want to have altogether. The digital twin is a very cool concept in order to get that. Yeah, because we can integrate key technical parameters of the stack, but also of the electrolyzer as well. And we can integrate a linking between different models, for example, CAD models, simulation models, mathematical models, etc. And therefore, in connection with the production itself, with various heuristics, with various mathematical formulas, we can gain some insights about the quality of a stack or electrolyzer for the future. In addition, what we have a look on is the support for all phases of the product lifecycle. That means from the beginning on, from the moment somebody is deciding that he wants to produce a stack or to sell a stack, until the disassembly or the recycling, we have one data model, standardized data model, where all needed information are included afterwards. Yeah, and as mentioned already, this topic is very important for me, and this is kind of my vision, to start as early as possible thinking about automation in context of stacking and in context of electrolyzer production. Because when we start to think about it as early as possible, we will get collectively results as early as possible, and we can achieve our goal collectively faster. And to share some insights, what might be some points to work on or to discuss about, we first of all have a wide range of opportunities to work on. And the last slide, I mentioned only 4, but there are a lot of other possible opportunities, and maybe some opportunities we don't know. We see some problems maybe in 1 year, and we have to challenge them. Yeah. The second point is the high degree of individualization. So we have a lot of stacks. We had a look on various stacks, also on electrolyzers, and we saw that each and every company has its own design, has its own methods, etc. And for us, a project who wants to get solutions for kind of an overall process, it is of course very hard to find these kind of solutions for various different products. And the last point, I tried to mention it by making the production picture bigger than the product picture. When we talk about technological leadership, what I mentioned in a lot of discussions, we talk about product leadership. So there must be a good product, and because we have the best product, we have the leadership in it. But maybe one point might be to think about the fact that technological leadership can also be gained by the production side. That means if we have the technology to produce the stacks faster, more efficient, more effective, etc., then that is also a technological leadership for us. And in combination with good products, good production systems, this might be one path we have to go in order to keep our production here in Europe and in Germany. Thank you very much. That was it.
Yeah, thanks, Robert, for the fresh start for our session, and it's good to see and interesting what you're up to. As we are streaming live on YouTube, we already have some questions from the audience. Maybe you can answer. I'll read it out. The user Uni4Y asked if you can give us a deeper insight of what ABB, for example, is doing within the project.
Yeah, of course. ABB, I think a lot of people know this company, is a big producer for robots and has very strong competencies in robots technologies. And with them together, we first of all define which kind of technology we need in order to get our automation done, first of all. So they bring a lot to the table when it comes to automation technologies. First of all, Then second point is in connection to human-robot interaction. We are working together with them in order to produce the electrolyzer as fast as possible. That was the third point on the slide, which I mentioned. Third point, and the third point maybe in regards of transportation. When we need to transport specific parts, we have some competencies in regards of transportation, AGVs, etc. To think about how these parts can be transported from A to B in order to be produced at some point.
Thank you. I hope this answers the first question because we have another. And the second question is, how big is the H2Giga project, and when it comes to project volume and the timeline? Could you refer to it a little?
Yeah, of course. Timeline, like we have 16 partners, 13 from industry, 3 from academia. Timeline is until March 2025, but we already started in summer or already in April 2021, I assume. Yeah. So overall, it's 4 years, but it is the normal timeline of the H2Giga project itself. So each and every project within H2Giga has this timeline. And volume, I assume, to be honest, not completely sure. I don't want to mention a wrong number here. So nevertheless, it is 3 numbers after the million. So it's
maybe Gregor can answer it.
Yeah, so Robert, maybe I can help out here a little bit. So the whole H2Giga project, because we are also part of H2Giga, we're also founded by the Federal Ministry of Education, and is in total 500 million euro over 4 years. So the total project volume of H2Giga. So it's a really, really big project where all electrolyzer companies in Germany are involved, and also a lot of companies looking on automation, how to manufacture and how to do the electrolyzer business, and how to really speed up the development in this field. So that's also one of the main targets of the H2Giga project.
Thank you. So if there are any questions from the audience, feel free to ask in the YouTube live chat. We'll try to keep an eye on it and don't get lost in our discussion so far. So thanks for the answers so far. Getting back to our main topic, as we know, green hydrogen will play a major role in the energy transition. And to produce green hydrogen, and a large number of electrolyzers will be needed. And for electrolyzers to be available on the market in sufficient quantities, and a partial automated assembly of both of the stacks and the overall electrolyzer has to take place. And starting off with the core component, the electrolyzer stack, I would ask to you, Gregor, where do you see the main potential of automated production, and where are the challenges to move in the right direction, and how could you at VAV adapt to it?
Yeah, let's first define what is a stack. Maybe you've seen already on the slides of Robert. So stack consists roughly, depends on a company in the world, roughly of 100 cells. Yeah, and inside of the cell you have 7 components at least, sometimes more or less. Depends really on a design of the cell. But let's talk about 7 layers you have to bring in to the whole cell. And now looking to the future, so we have a demand of gigawatts of installation, and breaking it down. So 1 gigawatt annual production capacity, is around, depends on the manufacturer in the market, between 15,000 and 500,000 cells per year, what you have to produce and to build together to one stack, 100 roughly per 100 cells per stack. So bringing it back, 15,000 to 500,000, let's take an average of it, 250,000 annual production. This brings us to 1,000 cells per day. It's a daily production. So something like, you have to be faster than 1 minute to produce on a 2 shifts day, faster than 1 minute per cell to produce it and to have it running. So from these numbers, it's directly clear it can only be done automated. Yeah? You need a lot of people otherwise to do and to assemble all of the cells at the end to one stack. So automation is a must and an enabler for the large scale manufacturing on the one side. On the second side, you need the quality. We are talking about hydrogen, oxygen as a product. So you need a high quality product and you need a low failure rate, at least at the customer side. Here you have zero tolerance at this point, because we are talking about hydrogen, and we all know about the high energy density. Otherwise, we would need it for the energy transition. So looking on automation is a topic of quality, speed, and it's an enabler for the whole economy in the future. And at the same time, you have to look a little bit, when you start with automation of your process. It's a little bit of a chicken egg problem, because you need a market, a large volume market, to run an automated facility or to plan and schedule and build up automated assembly and manufacturing site. On the other side, the customers buy only from you if you have already installed capacities. So it's some kind of chicken egg. So we have solved it for us. We decided that we have a roadmap and we will invest in our own site. So that's clear according to our roadmap. And you will find it very often inside of the market that you have announcements for automated manufacturing for stack production in the world, to overcome this chicken egg problem. On the same, what is the challenge on automation? If you automate a process, you know already what is your process, what is your product, how it looks like, and how it will look in 1 year. Now we are in a very, very young market, talking about very short development cycles with changing environment, and with changing legal regulations in the background, because there's nearly nothing regulated for electrolyzer plants. So the product is not really clear what will be produced in 3-4 years. So we have to design automated manufacturing lines, and this line must be able to adapt to new products. So it must be flexible and at the same time very reliable and so on. I think for the guys from production systems, is a lot of headache at the end of the day, because you have so many requirements to an automated process, which are contrary to each other. So maybe some inputs from my side and some views on this topic.
Thank you so much. The electrolyzer stack being complicated, as you pointed out. How is it on the assembling of electrolyzers? I would like to ask you, Harald. Is there a large difference, or do you face the same challenges at Gregor?
Thanks for the question, Robin. Let me take a broader look, maybe. As we are the electrolyzer manufacturer, automatization is key for the stack, as Gregor stated, for 2 main reasons: cost efficiency and, most important, quality. Therefore, when we started the BlueCube design concept, the BlueCube is a highly efficient, up to 3 megawatt electrolyzer in a 40 feet container. We did a deep dive into available technologies, and it was an easy decision for WEW. Not only they have the most convincing technology concept, which is alkaline water electrolyzers, but they also planned in automated stack production from the beginning. And this is giving us a great advantage in cost, reliability, availability in terms of capacity and quality. So the next step for BROCKHAUS Hydrogen is to increase automatization in the electrolyzer manufacturing process, and especially then when we have to realize projects in the 100 megawatt range with our BlueCube modules. And we believe that now is the right time to start that process. We are now in the process to involve experts like Robert and Idris to identify all relevant automatization opportunities in the production process. Of course, it is quite a complicated task to do that automatization process in the container, Well, we see some large opportunities when it comes to pre-assembly on a larger scale of capacity.
Okay, great. So I think we have a good match in our session today with bringing all the components of automation for building up electrolyzers. So every one of you is facing challenges, and they are so different. But if we before we assemble or before we automatize stack or electrolyzer production, we have this. We need this large input from you guys, from Gregor and Harald, how Idris and Robert can adapt to it by building their products. And at that point, I would ask, as you lay your hands on the topic every day, I'm interested in hearing what the challenges are that you face with all the potential pros. And do you face challenges where you need assistance of companies like BW and BROCKHAUS to get some input to get better at what you are doing every day?
Yeah, thank you for the question, Robin. Of course, we have a different point of view. The chair of production systems and the RIF, we are both a research institute, publicly funded research institutes, and we work in our daily life on researching and developing automated technologies for the electrolyzer and the stack production, and we see ourselves as experts in this area. But one of our main challenges is that we are not experts in the hydrogen electrolyzer and technology itself. Therefore, it's a big challenge for us to plan and establish the correct assembly conditions and consider the right quality restrictions. For example, for the automated assembly of a PEM stack, you need a clean room area, and finding out these kinds of information is not easy for us. A second challenge is that the current electrolyzer stacks, especially the ones we have observed in our research, are not suitable for the automated production. The design is mostly very old, complex, and the number of variety of different parts are too high to enable a fully automated production line for the electrolyzer and the stacking production line. Of course, we can develop automated solutions here too, but for meeting the increasing demand, it is very important for us to work with industrial partners, especially for the functionality of the stack, because we cannot test if the stack at the end of the day functions or not. Maybe I have to make clear that we both not interested in the producing of the stack of an electrolyzer stack. We are only interested in the automated technologies to improve and increase the stacking technology and to meet the demand for the huge demand in future which will become.
Maybe I can add something. I agree to 100% to Idris, who was mentioning all the big challenges that we have, but maybe we can broaden this topic up and not talking about challenges, but of chances. And one chance, what I see here when we talk about different or complicated designs of stacks, or big variation of designs, where we can get some input from practical partners is when we want to do, for example, our design for automation, where we want to discuss, okay, how is it possible to change, for example, a stack where it still has the same performance afterwards. Nevertheless, it is better to automize it, and to increase the output of the production. So this might be one chance where we can work together, should work together, in order to find best solutions for it.
Thank you. Good for mentioning the working together. Comes up to my next question. Did you guys already work together? Do you have projects together or have thought about it to make the automation happen?
Yeah, maybe I bring one answer to this question. I have also one additional topic of Idris, what he told already. So Idris, you mentioned that the existing technologies are, say, older and you cannot automate it in the right way. And this is totally true. I agree to this. Yeah, this is the reason why we started directly with the design to manufacturing on our stack side. So we are looking, you have to go hand in hand, manufacturing, assembly of a stack and designing a stack. It's really, it must go hand in hand. Otherwise, you cannot automate it. And in the end, you cannot manufacture hundreds of gigawatts in the next years. And coming back, we are working together, yes or no. So we had some exchange. We have some exchange meetings on some kind of global platform of H2Giga. We're not in the same project of H2Giga, not in a Fertig or they are also not in our star project. So here's a little bit differentiate. So we are here differentiated inside of the projects, but nevertheless we are in a loose exchange here and looking where we can help each other or what could be a real project to hand it over to the RUB, the University of Bochum.
Thank you so much. How are you doing at BROCKHAUS, Harald? Do you already have automated production, or are you getting into it right now?
So for us, we are right in the phase of bringing up our first prototype to stream. For us, it was the most important, as stated previously, to have a stack which is produced as much as possible automated at this state, because we are taking the advantage on cost efficiency and quality control in that sense. So therefore, we have already a big advantage implemented in our modular system, and taking it from there, it's the next step, as also stated before, to look into more opportunistic opportunities where automatization is a key. But that's just something which we are laying down in our design, which will come into play in the next coming years. That's depending on how quick the market is picking up to plants, to hydrogen plants, which are in the multi-megawatt range. Because I'm citing here Gregor, this is the chicken and egg problem to solve. You need to have the demand for that higher capacity to start to look into going from a more manual process in manufacturing to the automated process. Because then you need to ramp up production lines, which is a costly and very intense project for the whole team. And at that moment, we do have the discussions about those projects, which are very real. But give it a little bit more months and ask that question again. And I will come back to you with probably some much more realistic projections about what is the next step in electrolyzer manufacturing automatization processes.
Great. I'm happy we're doing this session today. So we are all getting connected and getting the best out of what we are doing every day. The thing is, you already mentioned like the whole pro side of like production and cost efficiency, the enhanced quality control, and the scalability of the products and the optimization. But I think we had some concerns of already. And what do you see critically on our topic of today? What are not the problems, but what leads to further challenges? Maybe, Robert, you're nodding, so we can maybe start.
Yeah, of course. I didn't know whether I have to start. Am I allowed to start?
Feel free.
Yeah, of course. Of course, one point, especially for smaller companies, when you implement an automation solution within your company, is the fact that you need your knowledge, and you need knowledge about the automation process itself, and you need to know the knowledge about the technologies itself. That means it is possible, but very hard. If you, for example, have an automatic solution with a robot included in it, of course, you need some basic knowledge about how does a robot work and how does it function, how we can change maybe in the future of it. This might be one challenge. And of course, you can do it with external partners. yes, who are planning for you and where you have your own connection to them, but you can also have it in-house at your company. Yeah, this might be two possibilities, and that might be, of course, one challenge. The second challenge is, of course, the possibility whether it is possible to automate at the state of the art right now. So we have, for example, in the stack some very complicated parts, porous parts, flexible parts, and we do not know whether it is possible to automate it to 100%. Yeah, this is something where we need to do some research about it. Yeah, and this is exactly the case. Not to say, okay, we want to automate from now on everything to 100%, but to work together and to ask exactly these questions. Hey, how is it possible to automate it? Yeah. Which kind of ideas do we have in order to automate it? And maybe it is, in some cases, very interesting to say, okay, we have an 80% automation and 20% manual handling. Yeah, because I don't know, the technology is not here. So this might be another challenge of it, in my opinion.
Great, thanks for the insight. Maybe other.
Robin, Robin, I have the opportunity to bring up topic which I see in the discussion is really not that prominent right now. We at BROCKHAUS Hydrogen thought also SWW design needs to be circular. And the automatization process doesn't stop in the manufacturing process, but it also need to be thought about when it comes to credit discussion here. So for us, it was very important to have that in mind and to select a technology with WEW, which is prone to be circular. BROCKHAUS is in the metal business and also in the metal recycling business. And for us, it was from the beginning a very important aspect that the electrolyzer and especially the stack can be recycled to 99.99, aka 100%. And that's also something where automatization will be key, because there is technology out there which contains PFAS, which contains precious metals, which all need to be recycled. And this is going to be, and I was involved in those projects, a very difficult to automatize task. For us, for the WEW stack, we are also thinking about having a fully automated recycling process, which will take us only about 1 hour to get all the components divided into the key metals, which can be then fully recycled in an automated process. We will expect for our electrolyzer quite a long lifespan. But after all these electrolyzers, all those tools are coming back to the original manufacturer, and then the recycling process is going to be key in driving cost. And therefore, I think the WEW stack integrated in the BROCKHAUS Blue Tube will give a very interesting approach into that full circularity, which can be fully automated.
Okay, maybe Idris can answer my question.
Of course.
We were talking about assembling stacks and building up everything. Have you ever thought about deconstructing it as well?
Yeah, of course. We bought some stacks and we tried to deassembly the stacks and show what are the challenges in the automated production and the automated assembly. We also thought about that, yeah, and we did it already with some stacks.
Okay, great, good to hear. So moving in the right direction.
Yeah, but this is of course something which is connected to each other. But of course, if you have a design where you can automatically produce a stack, yeah, or as much as possible, you also have the basis for the afterwards in order to disassemble it easier. So this is also something when we're talking about design for manufacturing. This is something which we have to have in mind at the first sight, yeah, to think about this. Okay, we want to recycle it afterwards, so we have to think about technologies or designs where we can disassemble it more or less very easy.
Great.
Maybe Robin, to your question before, one thing I want to add. I think in terms of the challenges, we have to see the potentials of the electrolyzer and stack productions. And only in Germany, the estimated need of hydrogen will be about 300 terawatt hour in 2045 in the industrial production. That means we will need a huge amount of electrolyzing technologies. And to meet the demands of the future and to be competitive in the global industry, we need automated processes. We have the optimal base, but I see it as a challenge that in terms of the adaptation times of these technologies, that it could be difficult. The adaptation times has to be much faster to meet the demands and especially to be competitive in future. And we should not only have the goal to build up electrolyzer manufacturers industry, also a supplier industry for the electrolyzer and stack manufacturing, like you can compare it with the automotive industry. That's maybe one of the challenges I see in terms of the automated production.
Okay, great. So, Gregor, maybe last question to you, or referring to it. What are your concerns at VEW, or is everything like perfect and it will work out in the near future, and we can start next week
That's
automation process?
yeah, automation is fine, and you have to look really on a full picture of a total plant and total installation. And we are starting a greenfield approach, and this is very unique in Germany to start a greenfield production site. You don't find the experts, especially on an IT base. Which kind of system do you take to steer your production site and to get all your values and data to one collective system? So usually you have a SAP or any kind of ERP system. You have already production systems in place, and then you try to find the IT landscape and to build around and to increase it and to start really from scratch. This is some kind of a hard topic. So we are today in a workshop with our cooperation partners here from universities to discuss this topic, about traceability through the factory, how to store the values, what to do with the data, what you get from the manufacturing and from the assembly, to do it in the right way directly from the beginning. And a greenfield approach, maybe we will have some person here in the auditory says, hey, I'm fully perfect engineer on IT systems and I know everything on a greenfield approach. Please call me, give me a call, and let's discuss this topic, because this is really crazy to find a person who tells you, okay, take this system and that one, and you can increase it by and extend by this and that one, and it will work out in the future. So it's a little bit also the same topic, because if you start with automation, you need a database, you have a lot of data available from your system, and you have to store it and bring it together to hold the production processes.
Yeah. And I think it might be hard to find the right personnel and employees for the company to get the machines going when they are installed.
Yeah, so from this point of view, to say we've not a big problem, because living or saying we are here in Dortmund, so we have a very good environment with a lot of good educated people in North Rhine-Westphalia. And of course, hydrogen and green energy and all this green topics helps to find new people, and because the company has a purpose in the world, and the people understand directly the purpose and are happy to work with us together. So we have a fast growing team and highly motivated team. So often it's easy for us to find new people from the location and the purpose topic. We see it in this way.
Great to hear that. Thank you for the insight. As I promised in the beginning, I told you we'll make this session short and crisp, and I would like to round that up for today. I think we had a good session, interesting one for us working together, and we learned a lot. Especially, I learned a lot today, even after reading myself into the topic, which was pretty new for me. I really like to thank you guys for being around, giving us the right insights for the session today. And I would like to thank everyone for joining the session, and to the audience to explore the future of green hydrogen and automation in the production of electrolyzers and stacks. I think we see that the potential is immense, and with increased efficiency, cost reduction, and higher production capacity on the horizon, it will be develop really, really great in the very near future. I think let's continue to collaborate on this and innovate together for a greener, sustainable future. So thank you guys that you were listening. Thanks to my panelists for today. Thank you for being with us, and please tune in for the next session of our H2UB Insights coming up in September. You will find the programming and the registration stuff on our website and even on LinkedIn. And maybe you're interested in our next topic. We will announce shortly. So far from me. Thanks for having me, for listening, and see you in the next H2UB Insights. And until then, goodbye. Thanks.